All right. So hopefully you've watched the first video about what a differential equation is and what it means to be a solution. Let's pick up where we left off there. I want to talk about some kind of technical details here just so that we understand what we're working with. So if you remember, we had just dealt with this differential equation and we had spent some time verifying that this was a solution. Oops, let's get that right. That this was a solution. 1/4 x to the fifth plus c x to the minus third. That equation was a solution to the differential equation. Or that function was a solution to the differential equation. We also talked about this idea that this c can represent any constant and it's still a solution. All right. So what we have here is what's called a general solution. All right. Because c is undetermined. It's a little like when you're integrating in calculus and you end up getting that plus c at the end. You don't know what c is exactly, but for any c it works. And so that's what we learn here. And we're going to see this a lot in differential equations. The solution to this differential equation is a whole family of equations where each one, the only difference is they have different values of c. All right. So I want to just show you what that means here. Here is the graph of y of x equals 1/4 x to the fifth plus c times x to the negative 3 for c equals 0. You can see right here that c equals 0 in my slider. And so that particular equation, that function, solves the differential equation. All right? But if I change sorry about that, we had some technical detail difficulties. But notice, so as I was saying, this curve satisfies the differential equation for c equals 0. But if c equals 1, say, that curve satisfies it. C equals 2, that function and its corresponding curve satisfy. So you have this entire family of functions and their corresponding graphs that satisfy this differential equation. All right. So when we have c as a constant, we don't know which one it is, and that's okay because we are happy to have any of these solutions. Now, occasionally they'll ask us to find a particular one, and by that they mean they want the solution that goes through a specific point. And if they give us a specific point to go through, then that gives us the ability to solve for c and come up with a particular solution, as opposed to this general family of solutions. So when we first start solving just differential equations, typically the solutions will be families of functions that solve them. But if we want a specific solution where we're given an initial value and a point that the solution has to go through, then that allows us to determine what c is. All right? And determine it specifically. So let's set this aside. Let's talk about something else real quick here. Maybe. Move that over there. We've talked a little bit about these being differential equations, and in fact, the title of this section is first order differential equations. So let's talk about some things here. We are going to be generally looking at what we call linear differential equations in this class. Not even generally, always. Linear differential equations. This is a linear differential equation. In order to be linear, a differential equation has to have all of the y's or derivatives of y's be to the first power. So you notice we've got the y here and its derivative. Those have to be to the first power in order to be linear. So you can't have, say, a y squared or a y prime squared as part of your equation. If you do that, then you're dealing with nonlinear differential equations, which is a whole different topic and much more complicated. But we're just looking at differential equations, all right? Linear differential equations. The other term that we're going to use here are, or at least in this particular section, we're looking at first order differential equations. The order of a differential equation has everything to do with the highest derivative, all right? So since our highest derivative in this differential equation is y prime, the first derivative, then it's first order. And so we have some of those terms that we're looking for. So be aware of those things. They'll come up in different questions and situations, but those are the meanings of those terms.